Good morning. This is probably going to be the last video for trig. This is chapter 5.4. It's about half angle formulas. So this is if I'm given an angle and I want to find the sine, the cosine, or tangent of half of that angle. So the first thing we're going to do is we're going to prove the cosine. Actually, we're going to use the sine of x because what I'm going to do is I am going to say that I know this x is if I call x theta over 2, then this 2x is theta, the original angle. So if I have the cosine of theta equals 1 minus 2 sine squared of theta over 2, so what I'm trying to do is I'm going to try to solve for that half angle. So what I'm going to do is I'm going to take this 1 to the other side. So I have cosine of theta minus 1 equals negative 2 sine squared of theta over 2. The next thing I'm going to do is I'm going to divide by negative 2. Now, what I'm going to have is now I'm going to have that sine squared of theta over 2 equals, now this is going to be a little bit confusing just because I don't want that negative. So if I wanted to pull that negative out, I would have 1 minus cosine of theta over 2. Just because I factored in basically a negative 1 out of here and then divided it and canceled it out. Now what I'm going to do is I'm going to take the square root. So I have the sine of theta over 2 equals plus or minus, because remember when I take the square root of both sides of an equation, I have plus or minus. I have plus or minus 1 minus cosine of theta over 2. Now, the biggest idea with this, and the proof for the cosine of theta over 2 is very similar. What that formula is going to be plus or minus the square root of 1 plus the cosine of theta over 2. Now, the biggest idea and the biggest confusion is where is theta over 2 going to be? So the confusion comes in when I talk about theta. Now, if theta is between 0 and 360 degrees and in quadrant 1 or 2, it's between 0 and 180 degrees. But I'm not concerned about theta. I'm concerned about theta over 2, or when I take that half of that angle, because I'm talking about the half angle formulas. Well, if I know theta is between 0 and 180, when I divide those by 2, theta is going to be between 0 and 90. So anything where the original angle is in quadrant 1 or 2, when I take half of that, it's going to be between 0 and 90 degrees. If theta is between 180, and 360, so it's in quadrants 3 or 4. When I take half of that angle, it's going to be between 90 and 180. So essentially, if it's in quadrant 1 or 2, and I take half of that angle, it's going to be in quadrant 1. If it's in quadrants 3 or 4, and I take half of that angle, it's going to be in quadrant 2. So my first example is if cosine of A is 3/5 with theta between 270 and 360. So that means it's in quadrant 4. So if A is between 270 and 360, when I find theta over 2, it's going to be between 135 and 180. So I know this is going to be in quadrant 2. So if that angle is in quadrant 4, and half of that angle is going to be in quadrant 2. So when I go to find sine of A over 2, I'm going to have plus or minus. Well, since this is in quadrant 2, sine is positive in quadrant 2. Now, Since it's positive in quadrant 2, I'm just going to erase this. Then what I'm going to do is I'm going to plug this 3/5 in for cosine of A. Now, the next thing I'm going to do is I'm going to get common denominators. So I'm going to call this 5/5. 5/5 minus 3/5 is 2/5 over 2 square root. The next thing I'm going to do is I'm going to keep change flip. So I have 2/5 times 1/2. Remember, division by 2 is the same thing as multiplying by half. So I'm going to have the square root of 1 over 5. Now, the thing about that is I'm going to take the square root of the top, square root of the bottom, and then I'm going to rationalize that. So that is going to be 1 over the square root of 5. When I rationalize that, it's going to be the square root of 5 over 5. Next, the cosine of A over 2. Now, since cosine is negative in quadrant 2, I'm going to use the negative square root. The formula for that is 1 plus the cosine of A over 2. Like the first one, I'm going to plug this 3/5 into cosine of A. So that's going to be negative square root of, this is going to be 5/5 plus 3/5 is 8/5 divided by 2 is the same thing as the negative square root of 8/5 times 1/2, which is the square root of 4/5, which is 2 square root of 5 over 5 when I rationalize that. Now, since this is in quadrant 2, I know tangent should be negative as well. Now, the next thing I'm going to do is to find the tangent of A over 2. What I'm going to do is I'm just going to put the sine over the cosine. So I'm going to have the square root of 5 over 5 times the reciprocal of this, which is 5 over 2 square root of 5, negative. Those are going to cancel, and the square roots will cancel, so it's going to be negative 1/2. So the sine of A over 2 is going to be positive square root of 5 over 5. The cosine of A over 2 is going to be negative 2 square root of 5 over 5. And the tangent of A over 2 is going to be negative 1/2. That's in quadrant 2 because all of those signs line up. Now, the next one is if sine of A equals 12/13 negative. Let's go with B. And B is between 180 and 270. Well, when I go to find B over 2, or half that angle, it's going to lie between 90 and 135. So I know this is in quadrant 2. Now, the next thing I know is that the original B was in quadrant 3. Now, all of these formulas do not use the sine of B. They need the cosine of B. So I'm going to use the Pythagorean theorem. I'm going to use that sine squared of B plus the cosine squared of B equals 1. And then solve for the cosine of B. So I'm going to, once I squared negative 12/13, so that's going to be 144 over 169. Cosine squared of B. Now I'm going to take that to the other side. That's going to be 25 over 169. Now when I take the square root of that, it could be plus or minus. Since this was in quadrant 3, cosine of B will also be negative. So that's going to be negative 5/13. Now this is what I'm going to need to use those formulas. So I'm going to go back and I'm going to find the 6 trig functions of B over 2. So the sine of B over 2, since B over 2 is in quadrant 2, it's going to be positive. I'm going to have 1 minus the cosine of B over 2, the square root of that. So I'm going to do this pretty quickly. I'm going to have 1 minus negative 5/13, which is plus 5/13 over 2. This is going to be 18/13, and then multiplied by a half. So that is going to be the square root of 9 over 13. Sorry, square root of 9 over the square root of 13. So that's going to be 3 over the square root of 13, which is square root of 13. 3 square root of 13 over 13. Now, that's the sine of b over 2. To find the cosecant of b over 2, I'm just going to flip this one. So that's going to be the square root of 13 over 3. The next thing I'm going to do is I'm going to find the cosine of b over 2. So I'm going to use that b over 2 is going to be negative in quadrant 2 because cosine is negative in quadrant 2. That's going to be 1 plus cosine of b, which is negative 5/13 over 2. So this is 13/13 minus 5/13 is 8/13 multiplied by a half, and the square root of the negative square root of that. That's going to be square root of 4 over square root of 13, which is negative 2 square root of 13 over 13 once I rationalize. The secant of b over 2 is going to be negative square root of 13 over 2 by just taking the reciprocal of this with the square root of 4 being 2. Now, I could use the tangent formula to find the tangent of a over 2 or b over 2, but what I'm going to use is just sine over cosine. If I take sine, which is 3 over the square root of 13, cosine, which is 2 over the square root of 13, but I multiply by the reciprocal because I divided. What it's going to be is it's going to be 3/2. That is the tangent of b over 2. And then the cotangent of b over 2 would be negative 2/3. Now, there is a couple equivalencies for tangent of theta over 2. The two equivalencies, let's do theta, is sine of theta over 1 plus the cosine of theta. That is the same thing as 1 minus the cosine of theta over sine of theta. Now, to find the tangent of 15 degrees, what I know is I can call that the tangent of 30 degrees over 2. Now, this is a half angle formula that I know because I know the sine and cosine of 30 degrees once I put theta in here. So I'm going to use this one. So I'm going to do the sine of 30 over 1 plus the cosine of 30. Now, this one's going to be a little bit math heavy. I'm going to go pretty quick. Sine of 30 is going to be 1/2. This is from your unit circle. This is 1 plus the square root of 3 over 2, which is the cosine of 30. Now, the next thing I'm going to do is I'm going to get common denominators. So I'm going to have 1/2 over 2 plus the square root of 3 over 2 by getting common denominators because this is 2 over 2. I'm going to take the top, multiply it by the reciprocal of the denominator. Those are going to cancel, so I have 1 over 2 plus the square root of 3. Now, this is going to be not in a form we want because technically we have a radical on the denominator. So if it's a quantity on the denominator, I'm going to have to multiply by the conjugate. So I'm going to do 2 minus the square root of 3 on the top and bottom. That is going to be the way we get the radical off the bottom. 1 times anything is itself, so I'm going to have 2 minus the square root of 3 over, when I multiply those together, I'm not going to have to do the O and the I of FOIL just because they're going to cancel out. So it's going to be 4 minus 3, which is 2 square root of 3, or sorry, 2 minus the square root of 3 over 1. And that's going to be my final answer for this one. The next thing I have is I have 2 proofs. If I have the sine of x over 2 equals, actually squared, equals tangent x minus sine x over 2 tangent x. Now the first thing I'm going to notice is that this is squared. So the first thing I'm going to do is I'm going to use the sine of x over 2 formula. That is going to be 1 minus the cosine of x over 2 plus or minus the square root of that. Now, the issue with that is when I use this squared, what that's going to do is it's going to square the whole thing. Now, what's going to happen is that's going to get rid of this square root because the squared is going to cancel that out. So I'm going to have 1 minus the cosine of x over 2, and that's going to equal tangent x minus sine x over 2 tangent x. Now, the next thing I'm going to try is I'm going to look to that other side, and do you see how the only thing I need to get from this side to this side is multiplying by tangent of x. That should key me in that that's what I'm going to have to do. I'm going to multiply both the numerator and the denominator by tangent of x. Just because I know 2 tangent of x is 2 tangent of x, once I distribute that, tangent of x times 1 is tangent of x. And then I'm going to do minus tangent x cosine x once I do that. Now, the only key to that is that this is not sine yet. But I should know that once I change it into terms of sine and cosine, it should be because everything else is lining up. So I have tangent x minus, tangent x is the same thing as sine over cosine, times cosine over 1. So these are going to cancel, and I have tangent x minus sine of x over 2 tangent of x. And that's the first proof. Here's going to be the next one. Now I do have 2 equivalencies for the tangent of anything or the angle over 2. So that is sine, we'll use a over 1 plus cosine a, or 1 minus cosine of a over sine of a. Now, when I go up and do this one, I know this one's going to be tangent, this one's going to be cotangent. So this is going to be cotangent, negative 2 cotangent of a. So I'm going to use this equivalency just because I'm going to think that cotangent is cosine over sine. So I'm going to go with this one. The next one for cotangent of A, I'm going to use this one, but take the reciprocal because I know tangent is 1 over the cotangent. So I'm going to use 1 plus the cosine over sine. Next thing I'm going to do is I'm going to erase this so I have more room. Now, the big key to this one is that I'm subtracting this whole thing. I'm going to split that fractions up, split those fractions up. I have 1 over sine of A minus cosine over sine of A minus, so I'm going to do 2 steps. I'm going to break this up here and then distribute it. So I have 1 minus the sine of A, and then minus cosine A over sine A. This is going to cancel with this. One's positive, one is negative. And then I have -2 of this. So I have -2 cosine A over sine A. And that is -2 cotangent of A. And that is it. Now, in your homework, they're going to have you graph half angle formulas. So if I was graphing 2 I think this is actually one of the examples, so I'm going to see how many people are actually watching these videos. What I'm going to do is, if I do that, and then I put the sine formula, square root of 1 minus the cosine of A, or x over 2, and I square it because this square is here, that's going to cancel this square root out. So I'm going to have 2 times 1 minus cosine of x over 2. Those 2's are going to cancel out. I'm going to have y equals 1 minus the cosine of x. And then I'm just going to do ABC, amplitude, period, phase shift, vertical shift with that. With this, so it's going to reflect the amplitude and then shift it up 1 unit. That should be it. That should help you with that last, or a couple of those problems. Please let me know if you have any questions.